Hello and welcome to the class on average effect and breeding value. The average effect of an allele is defined as the mean deviation from the population mean of individuals who have received that allele from one parent, and it is assumed that the gene transmitted from the other parent having come at random from the population. To understand the concept of average effect of an allele, suppose there is a locus with two alleles, dominant A and recessive A. In that case, capital A will denote homozygous dominant genotype, capital A small a will denote heterozygous genotype, and small a will denote homozygous recessive genotype. The average effect of dominant and recessive alleles are calculated independently. Now, suppose we are interested to calculate average effect of dominant A allele. In the given population, all the homozygous dominant A and heterozygous A individuals have one dominant A allele. The other allele is either capital A or small a. Homozygous recessive small a individuals will not be considered since they lack a dominant capital A allele. Now, according to the definition of average effect, we need to consider the mean deviation of homozygous dominant and heterozygous individuals from the population mean. The mean of homozygous dominant and heterozygous individuals is taken as small p multiplied by small a plus small q multiplied by small d, where small p represents frequency of dominant allele, small a represents genotypic value of homozygous dominant genotype, small q represents frequency of recessive A allele, and small d is the genotypic value of heterozygous genotype. The mean of homozygous dominant and heterozygous genotypes is taken as PA plus QD, where P multiplied by A represents that dominant A allele is united with another dominant A allele in the population, and Q multiplied by D denotes that capital A allele has united with recessive A allele in the population. Now, this mean of homozygous dominant and heterozygous genotype, that is PA plus QD, is to be taken as a deviation from the population mean to get an average effect of dominant A allele. The average effect of an allele is represented with the alpha, and the average effect of dominant allele is calculated with the formula PA plus QD minus A into bracket P minus Q bracket complete plus twice PQD, which upon solving yields the formula of average effect of dominant allele as Q multiplied by into bracket A plus D into bracket Q minus P bracket complete. On the similar grounds, the average effect for recessive allele can be calculated using the formula minus P multiplied by A plus D into bracket Q minus P as shown in this table. Here you can see the formulas for calculation of average effect of dominant capital A and recessive small a allele. The average effect of a gene substitution is taken as the difference between the average effects of the two alleles in a population, and which is calculated by formula alpha 1 minus alpha 2, and therefore the average effect of a gene substitution can be calculated with the formula A plus D multiplied by into bracket Q minus P. The average effect of gene substitution describes the change in the population mean when one allele, say dominant A, replaces another allele, say recessive small a, at the same locus. The concept of breeding value can be explained with the help of average effect of an allele. The sum of average effect of all the alleles affecting a particular trait is called the additive genetic value or breeding value of an animal for that trait. Now, since the average effect of the genes cannot be measured, but still we can estimate the breeding value. Here the breeding value is estimated with the help of definition. The value of an individual as judged by the mean value of its progeny for a trait is called the breeding value of that individual. Now suppose if an individual, a parent, is mated with a large number of individuals of other sex taken at random from the population, then its breeding value is twice the average deviation of its progeny from the population mean, and it can be described with the formula breeding value, which is represented with the letter capital A, is equal to twice into bracket progeny mean minus population mean, bracket complete. Now, since each parent transmits a random half of its genes to the progeny, the breeding value of an offspring equals the average breeding value of its two parents, such as breeding value of offspring is equal to 1/2 the breeding value of sire plus breeding value of the dam. Based on this talk, we have two exercises as your homework. First problem states that a trait is governed by two alleles, dominant B and recessive small b. The phenotypic values of various genotypes are measured under uniform environment. Based on the following information, calculate the gene frequencies small p and small q, estimate the genotypic values small a, small d and minus a, and determine the average effect of alleles dominant B and recessive B, and also estimate the average effect of allele substitution. Second problem is based on breeding value. The problem states that if 5 daughters of a bull averaged 4000 kilograms milk and their dam's average was 3500 kilograms milk, then calculate the breeding value of the sire for milk. Thank you.